Welcome to another helpful guide for your job hunt. Today, we're diving into the world of signal integrity engineers. If you're prepping for an interview for this role, you're in the right place. We'll go through key questions you might face and how to tackle them confidently. Let's kick things off with our first question. Can you tell us about a time you collaborated with a cross-functional team to address a signal integrity problem? This question is really about understanding how well you work with others, especially when it comes to solving technical challenges together. To make a strong impression, here's what you should focus on. Clearly define the signal integrity issue you encountered. Describe your role and how you worked with team members from other departments. Discuss the methods or tools you used to address the problem. Highlight the results and what you learned from the experience. Emphasize the importance of communication and teamwork. Let's look at an example of how you might structure your answer.
In my previous role, we faced a severe crosstalk issue in a high-speed board design. I collaborated closely with the layout engineers and the FPGA team. We conducted a series of simulations using SPICE and reevaluated the layout. Our teamwork led to a successful redesign that reduced crosstalk by 30%, enhancing both signal integrity and performance.
By the way, we're only covering a handful of questions in this video, but I've prepared a free PDF with all 30 top interview questions for signal integrity engineer. It also includes example answers and tips to help you prepare with confidence. The download link is just below. Can you share an example of a project where you took the lead in addressing signal integrity concerns? This question is designed to gauge your leadership abilities and how you take charge of solving technical issues. Here's how you can structure your response effectively. Clearly describe the project and your specific role. Highlight the signal integrity issues you identified. Explain the actions you took to address those issues. Discuss the outcomes and improvements in performance. Use metrics or results to quantify your success. Here's a sample answer to guide you.
In a recent PCB design project, I led the effort to resolve signal integrity issues related to high-speed data lines. We identified excessive crosstalk between traces, so I implemented controlled impedance routing and adjusted the layout, which improved the eye diagram by 30%.
Describe a situation where you had a disagreement with a team member over a design decision impacting signal integrity. How did you handle it? This question seeks to understand your conflict resolution skills and how you handle technical disagreements. Consider these points when forming your answer. Identify a clear instance of disagreement. Explain the technical aspects that were in conflict. Describe how you approached the conversation respectfully. Mention any compromise or solution that was reached. Highlight what you learned from the experience. Here's an example to illustrate this.
In a recent project, a team member suggested using a particular capacitor that I believed would adversely affect signal integrity. I scheduled a meeting to discuss our perspectives, presented data supporting my concerns, and we ultimately agreed to test both options before making a final decision. This helped us maintain a positive relationship and improve our design.
Imagine a scenario where a high-speed digital line exhibits unexpected signal distortion. How would you approach troubleshooting this issue? This question tests your troubleshooting skills and how you methodically address technical problems. Here's how you can break down your response. Identify the symptoms of signal distortion, such as ringing or bit errors. Use an oscilloscope to visualize the signal integrity and pinpoint the distortion. Check components like termination resistors, connectors, and PCB layout for issues. Simulate the signal path with signal integrity software to analyze and predict problems. Consider modifying the system, like adjusting impedance or adding conditioning circuits. Let's review an example response.
First, I would observe the signal waveform on an oscilloscope to identify any specific distortion patterns, like ringing. Then I would check the termination resistors and ensure the PCB traces are properly designed. If needed, I'd use simulation tools to model the signal integrity and assess any possible improvements.
Your team is experiencing EMI issues in a new design. What steps would you take to identify and mitigate the source? This question evaluates your problem-solving skills, particularly in handling electromagnetic interference in designs. To answer effectively, consider these steps. Review the circuit layout for potential ground loops and improper shielding. Use an EMI scanner or spectrum analyzer to locate frequencies causing interference. Check signal integrity through simulations and measurements to identify problem areas. Implement filtering solutions like ferrite beads and capacitors in critical locations. Consider redesigning the layout to improve separation of high-frequency signals from sensitive areas. Here's how you might respond.
First, I would analyze the PCB layout for any ground loops and ensure proper shielding is implemented. Then I would use a spectrum analyzer to pinpoint the frequencies responsible for the EMI issues. Finally, I would apply filters at critical points to mitigate the effects.
Before we wrap up, remember you can get all 30 questions, example answers, and step-by-step tips in a handy PDF. Totally free, just grab it below.